We now solve problems on confidence interval. To solve such problems, we need to first remember we need some basics. The first thing which we need to by heart are the Z values. Z values. Remember, for 95% confidence interval, the Z value is 1.96 is the Z value. Also remember one thing, 95% means 5% level of significance. This is called level of significance. Similarly, for 99% confidence interval, which is 1% level of significance, the Z value is 2.58 is the required Z value. This is something. Remember one more thing you have to remember is confidence interval for binomial distribution is x bar minus z into sigma into x bar plus z into sigma. Apart from the z values, you need to remember this confidence interval for binomial distribution formula is x bar minus z into sigma into x bar plus z into sigma. Here the formula for x bar is n into p, sigma is root of n p into 1 minus p, where n is number of observations, p is probability of success. Probability of success. Good. Similarly, confidence interval for normal distribution is confidence interval for normal distribution is x bar minus z into sigma by root 10 into x bar plus z into sigma by root 10. Then in this case your x bar is sample mean, sigma is sample standard deviation, and n is sample size. Now, we solve the first problem here. A coin was tossed 400 times and head was obtained 216 times. Tester claimed that the coin is unbiased at 95% level of confidence. Now, first thing is the Z value thing we already know. Now, the thing is there are two types of confidence interval, one for binomial distribution, one for normal distribution. So we need to identify which problem falls under binomial distribution, which problem falls under normal distribution. Now, the problems which have got only two outcomes will fall under binomial distribution. For example, a coin was tossed 400 times and head was obtained 216 times. When a coin is tossed, there are only two outcomes. Either you get a head or either you get a tail. So this suggests the following problem needs to be solved using binomial distribution. So in binomial distribution, the confidence interval is z x bar minus z into sigma into x bar plus z into sigma. We need to know what is x bar, z, sigma. Now x bar has a formula which is nothing but n into p. Now in this case, since it's a problem of binomial distribution, we need to define a success as, now a coin was tossed 400 times and head was obtained. So if you observe that whenever we are tossing a coin in this problem, we are interested in the outcome of getting a head. Therefore, our success is getting head. Our failure is of course not getting head. This is something which has to be defined. First, once this is defined, we now move with the confidence interval part. Confidence interval part is x bar minus z into sigma into x bar plus z into sigma. Three things we don't know: x bar, z, sigma. X bar is given as n into p. N is the number of times the experiment is repeated, which is 400. Now p is the theoretical probability of the experiment. Theoretical probability. That means the probability which is obtained through theory. Whenever you toss a coin, the chances of getting a head are half. Therefore, the probability is 1 by 2. This is the theoretic probability. You don't have to calculate it using anything from the problem. This you have to calculate using theory. And therefore, n into 1 by p. And therefore, x bar is 200. Similarly, z is, since it is 95% confidence, the z value for 95% confidence is 1.96. So z is also 1.96. Second thing done. The third thing which is left is sigma, and the sigma is square root of np into 1 minus p. This is square root of np is already found. If you observe, np is already found as 200. So this np part is replaced by 200, and we are left with 1 minus 1 by 2. This we are left with 200. 1 minus 1 by 2 is half. This is root 100, and this is 10. So we have got everything. We have got x bar, we have got z, we have got sigma. So now we find confidence interval, which is nothing but x bar minus z into sigma into x bar plus z into sigma. X bar is 1.96. No, x bar is 200. Z is 1.96. Sigma is 10. So we insert that, comma, x bar plus 1.96 into 10. This is 200 minus 19.6 into 200 plus 19.6. This is 180.4 to 19.6. This is our confidence interval. Now, the question was asking is, test the claim that the coin is unbiased. Now, the 206 that is obtained here is the testing value. The answer that is obtained here is the testing value. Now, how 216 lies between the two numbers. So we say that since 216 lies between 180.4 and 219.6, the claim is accepted. If the value 216 did not lie between them, we have to say that the claim is rejected. We solve another problem. In a row of fixed base dice, odd points were obtained 180 times. Would you say that the die is fair at 5% level of significance? Now let me recollect. The 5% level of significance is nothing but 95% CI. So this is actually same as 95% CI. Also, now in this case also we are drawing a die and we are interested in getting an odd point. So it's like this is also something like a binomial distribution, wherein you can define success as getting odd points and failure as getting even point. Success is getting odd, failure will be getting or not getting odd, whatever it is, not getting odd. The n is 324 because we are repeating the experiment 324 times, and the p in this case is the probability of getting odd points when you draw a die. When you draw a die, the possible outcomes are 1, 2, 3, 4, 5, 6. Among this, the chances of getting odd are 1, 3, 5. These are 3 out of 6, which is 1 by 2. Now, we again use the same formula. The confidence interval is x bar minus z into sigma, comma, x bar plus Z into sigma. We need to find x bar. X bar is NP. N is 324 if you observe here. N is 324. P is half, which is 162. Sigma is root of NP into 1 minus P. Root of NP is found to be 162. 1 minus P is what? 1 minus half, which is 162. 1 minus half is half. This is root 81. This is 9. And Z for 95% CI is what? For 95% CI, the Z value is, as we formed from the table, is 1.96. This you have to by heart. And now we insert all the values. CI is equal to x bar 162 minus Z 1.96 into 9. 162 plus 1.96 into 9. This is 162 minus 1.96 into 9 is, we'll have to find out using calculator. 17.4, 17.64, and this is 162 plus 17.64. This is coming out to be 162 minus 17.64, which is 144.34, and this is 179.64. Now if you observe that the testing value is 180 in this case, since 180 does not lie in between them, we say that claim is rejected. We now solve another problem. The mean height obtained from a random sample of size 100 is 64 inches. The standard deviation was found to be 3 inches. Test the claim that the mean height of the population is 67 at 95% confidence interval. Now, problems involving mean height, average life have to be solved using normal distribution. For normal distribution, the formula is, confidence interval is x bar minus Z into sigma by root n into x bar plus Z into sigma by root n. X bar is sample mean. The sample mean is the mean height from a random sample is of size 100 is 64 inch. So that means the mean height of a sample of size is 100. That means, but the mean height is 64. So x bar is 64. Sigma, the standard deviation, is found to be 3. So this is 3. And the mean height from a sample size 100. So that means n has to be 100. So now we insert all of them. This is 64 minus Z is of course the 95%. So Z is 1.96. 1.96. Sigma is 3 into root 100 into 64 plus 1.96 into 3 by root 100. We get 64 minus 1.96 into 3 by 10. 64 plus 1.96 into 3 by 10. This is 64 minus 1.96 multiplied by 3 is 5.88. 5.88 upon 10. 64 plus 5.88 into 10. 64 minus 0.588. 64 plus 0.588. This will be 64 minus 0.588 is 63.412, and this is 64.588. Now in this case the testing value is 67. 67 does not lie here, so therefore we say that claim is rejected. If you observe that the 67 does not lie between 63 and 64, so therefore the claim is rejected. Similarly, we solve another problem. A company says that the mean life of bulbs produced by them is 1600 hours. To test this claim, a sample of 400 bulbs were tested and their mean life was found to be 1570 hours and a standard deviation of 150 hours. Test the claim at 1% level of significance. Let me recollect, 1% means 99% CI. Now, this is again a problem involving mean life, so it has to be solved using normal distribution. Confidence interval is x bar minus z into sigma by root n, x bar plus z into sigma by root n. We now say the x bar is the sample mean. Now, the company claims that the mean life is 1600. This will become your testing value. Whatever is the claim will become your testing value. The other value for mean life that is given will be used as x bar. Because it is associated with the mean sample, it is associated with the word sample. So to test this claim, a sample of 400 bulbs was tested and their mean life was found to be 1570. So therefore the sample mean is 1570. The standard deviation is 150. The sample size is 400 and the Z value is 2.58. This is because of the 99% CI. So we now do 1570 minus 2.58 into 150 upon root 400 into 1570 plus 2.58 into 150 upon root 400. This is actually 1570 minus 2.58 into 150 upon root 400 is 20. It is 1570 plus 2.58 into 150 upon root 400 is 20. This is 1570 minus 2.58 into 7.5. 1570 plus 2.58 into 150 upon 2 is 7.5 that you can do, and this calculation will be 1570 2.58 into 7.5 is 19.35, and this is 1570 plus 19.35, and this is value will be 1551.65, 1589.35. Now if you observe, the testing value is 1600, which does not lie here, therefore we say that it is rejected.